Welcome to this explainer. Every system we build, every model we train, and every insight we generate basically hinges on a fundamental taxonomy of information. Today we're going back to the structural roots of data management to really examine the strict dichotomy between qualitative and quantitative data. Understanding how to architect for both of these distinct domains is absolutely crucial. It's literally the foundation of modern analytics, robust system architecture, and effective database design.
So, here's our roadmap for today. We'll start with a welcome to data management. Then we'll define raw data, explore qualitative data, examine quantitative data, and finally, we'll be comparing the two types.
All right, let's dive into Section 1. Welcome to data management.
Okay, so data management isn't just a single action like hitting save on a spreadsheet. It's an entire complex ecosystem. Managing data at scale involves looking at different structural types, engineering highly effective pipelines to collect and store information, and deploying some pretty sophisticated methods to analyze vast lakes of data. It ultimately culminates in visualizing that data through complex charts and enterprise tools. This is a massive, highly structured undertaking that turns unknown variables into concrete, actionable business intelligence. And honestly, failing to understand the core types of data at the very beginning of this pipeline inevitably leads to cascading structural failures downstream.
Let's move along to Section 2, defining raw data.
So what actually is it? Well, data consists of raw facts collected about things around us that we can process to generate useful information. The critical distinction here centers entirely on that word raw. In system architecture, data starts as completely unstructured, unrefined inputs. It's essentially just the raw material logging events, states, or attributes. It only becomes useful information, the kind that actually drives executive decisions or algorithmic predictions, after we apply processing, filtering, and rigorous analysis.
And this brilliantly illustrates that raw data takes many forms, originating from an endless variety of sources. Managing numbers in short text fields is largely a solved problem, right? Traditional relational databases handle that easily. But today's data environments also have to process complex measurements and open-ended observations. Plus, with the exponential rise of machine learning, we're increasingly architecting systems to process highly unstructured inputs like images and sounds. Understanding these diverse forms is exactly why defining our data inputs correctly from the outset is a real game changer for building scalable systems.
Which brings us to Section 3, exploring qualitative data.
Qualitative data refers to categories or labels used to describe the qualities, characteristics, opinions, and behaviors of something rather than its quantity. Here, we need to focus strictly on the concept of qualities. In any data architecture, qualitative data acts as the crucial metadata. It provides the essential context that actually gives our numerical data its meaning. It tells us the what and the who behind an event, offering deep descriptive insights without ever relying on counts or measurements.
Think about a classroom or a student in a learning management system. The names Ali, Badar, and Kasim are perfect examples of fundamental qualitative labels. In a database, these aren't just display names. They often serve as primary keys or vital categorical dimensions. They don't represent an amount or a scalable value. They describe the attribute of identity, labeling the specific entity so that we can later attach meaningful actions, histories, or metrics to them.
Now, what's really interesting about this slide are the two defining traits of this qualitative world. First, it's strictly non-numeric, represented entirely by words, labels, or discrete symbols. Second, and crucially for analytics, it is categorical. It allows us to divide records into logical classes based on shared characteristics, like tagging inventory by types of fruit. This categorical trait is the absolute foundation for user segmentation, cohort analysis, and grouping data in any business intelligence tool. You aren't calculating the labels, you're using them to organize the chaos.
Let's pivot over to Section 4, examining quantitative data.
Let me ask you this. If you're querying a database and your primary requirement is answering how much or how long, guess what? You've officially crossed over from the descriptive realm and into the purely quantitative realm. Quantitative data consists of numbers used to measure the quantity or amount of something for mathematical calculations and statistical analyses. While qualitative data provides the context, quantitative data is the raw mathematical fuel. It's the lifeblood of financial forecasting, complex regression models, and algorithmic training sets. In this domain, mathematical operations completely govern how we extract value and identify patterns from our records.
Take a value like 100. It perfectly represents the core nature of quantitative data. It's a measurable digit that denotes exact precision and scale. Whether it's a discrete value like a test score or a continuous value like a specific height down to the millimeter, it gives data scientists the concrete numerical inputs necessary to track trends, calculate variances, and measure exact performance metrics over time.
And this quantitative domain operates under its own strict set of traits. First, it's numerical, expressed entirely in numbers, making sorting and indexing highly efficient at scale. Second, it's measurable. You capture it using instruments, allowing for precise tracking of physical states like server temperatures. Third, it's countable. These are discrete items, vital for tracking inventory volumes or daily active users. And finally, it's arithmetical. It supports mathematical operations, which is fundamentally impossible with qualitative labels. I mean, you simply cannot multiply an apple by a banana, right?
So the crucial point is how we use that arithmetical data to generate derived data. When we take a base unit price and multiply it by a measured weight, we produce a total price. While the math itself is super simple, this represents the vital concept of feature engineering. We're applying operations to raw quantitative data to create entirely new engineered metrics. Whether it's calculating total cart value in an e-commerce platform or aggregating annual recurring revenue from monthly fees, derived quantitative data is what actually populates your executive dashboards.
Bringing it all together, let's look at Section 5, comparing the two types.
A complete, powerful data set almost always requires a seamless marriage of these two types. On one side, qualitative data provides the words, labels, and attributes. On the other, quantitative data provides the numbers, measurements, and countable scale. In practice, you rely on the quantitative numbers to calculate performance and track growth, but you absolutely depend on the qualitative attributes to filter, group, and contextualize those calculations.
When deciding how to structure your database or design your analytics pipeline, always ask what problem you're trying to solve. If you need to group entities and answer what kind or which category, you've got to architect your tables to support words, labels, and symbols. However, if you need to calculate scale and volume to answer how much or how long, you architect strictly for numeric types and measurements. Understanding this logical split ensures data integrity from the moment a record is created to the moment it's visualized.
To lock in this framework, take a critical look at the very screen or application you're using right now. Consider the user interface in front of you. Challenge yourself to identify the underlying qualitative metadata, the account names, the labeled categories, the functional tags. Then separate that from the quantitative telemetry data the app is continuously tracking in the background, the exact session duration, the network ping rate, the precise pixel coordinates of your cursor. You're navigating through a complex matrix of this raw information every single second. The question is, how will you structure and process it into your next breakthrough insight? Thanks for joining me on this explainer, and I'll catch you next time.